So in this video, we're going to be looking beyond the unit circle at circles in general. And a circle in general that's centered at the origin has this equation here, that x squared plus y squared will equal r squared, where r is the radius of your circle. So here's a circle centered at the origin, and it has this point x comma y, right? So if I plug in x and then square it and add y and square it, I should get the radius squared. That makes sense because this is actually Pythagoras' theorem here. The 5 there is the radius, so that's r right there. X is like side A, right? It's close to the right angle. Y is side B. And Pythagoras' theorem is that a squared plus b squared equals c squared. That's really the same thing here, just where a is equal to x, b is equal to y, and c, the hypotenuse, is r, the radius. That's supposed to be an r there. So what's the equation of this circle? Well, it would be x squared plus y squared equals the radius squared, and here the radius is 5, and it's being squared. So that would simplify to just x squared plus y squared equals 25, and that would be the equation of this circle. All right, using that, this is the same circle. Using that, we can actually set up our primary trig ratios for different points on that circle. So say we're talking about the point 3, 4. So x is 3, y is 4. So that's this point right here. So I could draw a terminal arm to that point, and the angle would be this. That's theta, the angle. And this actually makes a little triangle, right? So it's a right angle triangle where this is the y part, and the x part is here. And then, of course, that's the radius there is 5. So you can see that y is going to be 4, and x is going to be 3 here. So x equals 3, and y you can see is at the point of 4. The radius, I can calculate you can read it off fairly easily here, but I can also, because you can see the radius goes up to 5 here, but if I couldn't read it easily, I could also calculate it this way. So I could do x squared plus y squared is the radius squared. I can actually plug in x, which is 3, and y, which is 4. That gives me r squared. So that gives me 25 equals r squared. So the radius, square both sides, the radius is 5. So I'll fill that in on my diagram here too. So that radius is 5 there. All right, knowing that, we can write down our 3 primary trig ratios. The first one is sine. Sine of your angle, in general, is, if I write down SOHCAHTOA here, right, sine is the opposite over the hypotenuse. So for us, the opposite side from this angle would be y, and the hypotenuse would be r. So the numbers there, the sine of theta is 4 over 5. For cos, well, cos of theta is the adjacent divided by the hypotenuse. The adjacent side is x here, and the hypotenuse is r. So cos of theta for this particular circle and that point on that circle would be 3 over 5. And last but not least, tan of theta in general is the opposite over the adjacent. So in our little triangle here, that would be y divided by x. And if I plug in the numbers for this particular circle, I have y is 4 and x is 3. So those would be my 3 primary trig ratios for the point 3, 4 on this circle. Let's look a little bit about calculating those angles then. So this is the same circle, right? So we know this point, right? This point is, this is 3, this is 4, this is 5. So sine of whatever this angle is would be the opposite divided by the hypotenuse, 4 over 5. Now how can I get the angle and know that that's actually 53.13 degrees? Well, what you do on your calculator is just that angle would be the inverse sine of 4 over 5. And your calculator will spit out an angle of 53.13 degrees when you do that. But there's actually another angle that has the same sine ratio. So in general, right, sine of theta is just y over r. Well, is there anywhere else on this unit circle that has the same y value and the same r value? Well, yes, actually. That point is over here. So right here, the y value is still 4, the radius is still 5. So that angle right there, I could call it maybe theta 2, has the same y value and the same r value, so it has the same sine ratio as my initial angle, which I could call maybe theta 1 here. Maybe I'll rename that guy theta 1. So it has the same, so that's the first angle, theta 1. Theta 2 has the same y, the same r, so it's going to have the same sine ratio, but it's a completely different angle. So how can I actually calculate what that angle is? Well, if I look closely here, you can see this is symmetric. So the whole angle all the way from here, I think I'm going to erase a few things so you can see better here. One sec. All right, so the whole angle from here all the way to there, that would be 180 degrees, right? This angle here is the 53 degrees, and we could call that maybe theta 1. Put a little 1 there for theta 1. And then the angle that I'm interested in is the angle to this point right here. And that we're going to call theta 2. So notice that this is a symmetrical thing. Theta 1 is 53 degrees over here. There's going to be a 53 degree angle in here as well. So that is also going to be, that will be the same size as theta 1. That's going to be a 53.13 degree angle right in there, just between 180 degrees and the purple line, which is the terminal arm I'm interested in. So how can I calculate theta 2? Well, theta 2 must then be 180 minus the theta 1, right? It must be, this is symmetric here. If that's 53 degrees here and that's 53 degrees there, then we must be able to do 180 minus 53 degrees to get theta 2. So minus the 53.13 degrees. So we can calculate that. So 180 minus 53.13 is 126.87 degrees. So that other angle, this sort of theta 2, has the same sine ratio of y over r as 53 degrees. And you could check it on your calculator. If you do sine of 126.87, you'll get the same value. You'll still get 4 over 5, or roughly 4 over 5, because we rounded our angle off to some decimal. All right, here's another one, same idea. So the cosine ratio of the same angle, 53.13 degrees, is 3 over 5. But there's actually another angle that has the same ratio. So remember, cos of theta in general is x over r, and that's how we got the 3 over 5 in the first place. So where else on this unit circle would have the same x value and the same radius? Well, the same x value of 3, that would happen right down here, and that point would have the same radius too. So my theta 2 in this case is actually this angle right there. So theta 2 has the same cosine ratio as theta 1. Let's just call that a theta 1. And notice there's also some symmetry here. If this is 53 degrees on that side of the x-axis, then this must also be 53 degrees down there. And so how I can calculate theta 2 will be by doing 360 degrees. So that's the angle to go like all the way around, right? To go sort of all the way to here, that's 360, and then back up by theta 1. So 360 minus theta 1. Or for us, 360 degrees minus the 53.13 degrees. And that is going to be 306.87 degrees. And so if you do the cosine of 306.87 degrees, you'll get 3 over 5, or really, really close to 3 over 5. We just sort of rounded off our angle a little bit. All right, the very last one. So tan of 53 degrees is 4 over 5. And so we got that using the fact that y is 4 and x is, sorry, 4 over 3. Y is 4 and x is 3. So what other angle would have the same y and the same x value? Well, actually, there's nowhere on this circle that has the exact same y value and the exact same x value, but there is another place on this circle that has the same y over x, right? So tan of theta in general is y divided by x. And if we make x equal to -3, but we also make y equal to -4, well, then what I would get is tan of theta would be -4 over -3, and the negatives would cancel, and I'd be left with 4/3. I'd be left with the same tan ratio. So even though neither the y nor the x value are the same at this point, y over x is still 4/3. Y over x would still simplify to the same tan ratio. So this angle right here is the theta 2 I'm looking for. This one's a little bit different than the last two we did. What you can see is happening here is I've got my theta 1 going on here, and then from there, this is like a straight line right across, right? So I'm adding another 180. That, I'll make it green here. So this angle right here is 180 degrees. That's half of the circle right there. So I'm taking my theta 1 that I start with, and I'm adding 180 to it to get theta 2. So theta 2 here would be that initial theta 1 plus 180 degrees. So for us, that would be 53.13 plus 180. And that gives me 233.13 degrees.